The first question, Mr. Chomsky, comes from Christos Goudreau. How have your ideas on universal grammar changed over the years? Are you more or less convinced of the theory now than you were initially?
Well, there's a lot of confusion about the notion universal grammar. Universal grammar had a traditional meaning, but in modern linguistics, last 50 years or so, it's had a technical meaning, which is not unrelated to the traditional meaning, but is not identical either. Universal grammar is just the name for the theory of the genetic component of the language faculty. I mean, transparently, there's some genetic component, right? There's a reason, say, why my granddaughter reflexively identified some part of her environment as language related, which is no small trick. Nobody knows how to duplicate that. And then more or less reflexively picked up the capacity that we're all now using. Whereas her pet, say, kitten or chimpanzee or songbird or whatever it may be, with exactly the same inputs, couldn't even take the first step, can't identify part of the environment as language related, obviously not the later steps. Well, there are two possible answers to how that happens. One is it's a miracle. The other is she has some specific genetic capacity that's like the capacity that had her grow arms and not wings, let's say. Just some fixed, or had a mammalian visual system, but not an insect visual system. Now, this is not controversial for anything except human higher mental faculties. For some reason, when people investigate human higher mental faculties, they have to be insane. You know, you can't accept the approach that we take to everything else in the world. The kind of a methodological dualism. Everything else in the world we study by the standard methods of science, but when we talk about human higher mental faculties, we have to become mystics. So therefore there's a controversy about the existence of universal grammar, which means a controversy about whether there is some genetic property that distinguishes humans from everybody else, which leads to to the ability to doing what we're now doing. But there shouldn't be any controversy about that. The only question is, what is it? Well, there have been theories about it from the 1950s when these studies began up till the present, and it's a living field, so they keep changing. So in that sense, yes, my views about universal grammar keep changing. Say when Anne walked into my office as a graduate student and told me I was wrong about everything, so okay, my views changed. But in that sense, sure, there's going to be constant change until the field disappears or is dead or something. And there's a long way to go. These are not trivial questions. At the sort of general tendency of change, not every linguist would agree by any means, so it's a personal opinion. In the early stages, when the first question was asked seriously about 50 years ago as to how we are capable of doing what we do all the time, how are we capable of understanding, producing expressions which we've never heard, which may have never been uttered in the history of the language, and do it over an infinite range, various strange properties that they have as soon as you look at them. How can we do it? The only answer seemed to be that each of us has a highly intricate computational system in the brain which yields these very specific results. But that then poses a paradox, because it must be the case that we all humans have the same genetic capacity with marginal variation. The reason is, if you take a child from, say, a hunter-gatherer tribe in the Amazon, and the child is raised in Cambridge, Mass, it'll may become a graduate student studying quantum physics at MIT with no difference from anyone else, and conversely. So we all have the same capacity, and it's more or less understood why. The capacity developed very recently in evolutionary time, and probably in some window between 100,000 and 50,000 years ago, something like that. And that's just a flick of an eye. So whatever happened never changed, except extremely marginally. So we're all fundamentally identical for all practical purposes. Human genetic variation is very slight anyway, superficial differences, but not very profound. An outside, say an extraterrestrial observer looking at us the way we look at frogs would say there's only one human and one language with minor variations. So on the one hand, it's got to be uniform. On the other hand, it seemed to be the case that each particular language had a highly intricate and complex system of rules, computational system, and they're very different from one another. And that is a paradox, in fact, a serious paradox. Well, over the years, there have been efforts to deal with it, to try to overcome the paradox. A major step was taken, and here views on universal grammar, at least for many of us, did change radically, was around 1980. You were there, yeah. It's her fault. When a different view of the matter sort of crystallized, what's sometimes called the principles and parameters view. The picture that that there are fixed principles which are really invariant. Nobody has to acquire them. They're part of universal grammar. And then there's a number of options that can be taken, called parameters, that the child has to pick up from experience. And they have to be pretty simple. You have to be able to pick them up from limited evidence, because that's all there is. So, for example, in some languages like English, it's called a head-first language. So the verb precedes the object, and a preposition precedes the object of the preposition, and so on. Other languages, like, say, Japanese, are almost the mirror image. The verb follows the object, the postpositions, not prepositions, and so on. So the languages are virtually mirror images of each other. And you have to set the parameter. The child has to set the parameter which says, am I talking English or am I talking Japanese? And that can be determined from very simple data. So that's a reasonable choice of a parameter. And the hope was that you could find some finite set of parameters, like a finite switch box, where you set the switch, the child has to set the switches one way or another, and can do it on the basis of fairly simple data. And then once this enters into a predetermined system of principles, you get things which superficially look very different, but are actually almost identical, just differing in superficial choices. Well, if you could work that out, you'd have solved the paradox. It's a long way to work that out. But that made it possible at least to confront the issue seriously without facing an immediate near self-contradiction. And it set off a lot of a really rich period of research and inquiry, and nothing like it in the thousands of years of history of study of language in the last 25, 30 years, of a wide variety of typologically different languages, new questions at a depth that could never have been proposed before, sometimes answers leading to new questions, and so on. It's been a very lively period. And it also raised another question. What about the principles? Where do they come from? And the fact, the choice of parameters. Where do these things come from? If they're in universal grammar, if they're part of the genetic endowment, then they had to evolve somehow. But not a lot could have evolved because it's too recent. You know, you go back 100,000 years, there's, as far as we know, nothing. Humans had the same anatomy. Anything that's preserved in the fossil record is about the same, you know, hundreds of thousands of years back. So some small change must have taken place in the brain, which somehow allowed all of this to suddenly blossom. And pretty soon after that, again in evolutionary time, like maybe a couple of tens of thousands of years, which is no time at all, humans started leaving East Africa, where we all come from, as far as anyone knows. So some small group developed this system and then spread all over the world, and now they're all essentially the same. But what evolved in that short period of time cannot have been very complex. You know, you wouldn't expect a series of extensive stages, like, say, development of limbs, you know, millions of years. Therefore, what you'd predict is that some other principle external to language, maybe some principle of nature, the principle of computational efficiency or something like that, which is not specific to language, interacted with a small mutation which just gave rise to universal grammar. Well, that sets forth a new goal of research, to see if you can determine that the principles themselves do not have the intricacy that they appeared to have, but are actually the result of application of non-linguistic, in fact, maybe non-human principles, like general principles of computational efficiency, to whatever small change took place. And the small change was probably the capacity to carry out recursive enumeration, basically, the capacity that gives you the number system, for example, to take two objects already constructed in the mind and make up a new object out of them, and then keep that process up indefinitely, so you get an infinite array of possible expressions, each with some semantic interpretation and some mode of externalization, speech, sign, whatever it may be. That would be, and the goal would be to try to show that that was essentially instantaneous. Once the small mutation took place, given this operation, the recursive enumeration operation, that allows you to create a discrete infinity of expressions, structured expressions. Well, that's at least a feasible picture. The trick is to show that it's true, or how close it is to true. Can you cut away at the apparent complexity of the principles and show that they can actually be accounted for in terms of general principles that hold for organisms generally, perhaps, and maybe even elsewhere in the physical world, and that are instantly or almost instantly applied once the original move is made to whatever small move it was to produce the capacity for recursive enumeration. Well, that's a goal. It's far from being attained, but in the last 15, 20 years, there's been considerable progress towards it. That is, a lot of things that it seemed 20 years ago you had to assign to the genetic endowment have now been rather plausibly shown to be possible consequences of just application, particularly of principles of computational efficiency, to a system which had only the ability to construct an infinite hierarchy of expressions. And that, we don't know enough about the brain to know how that might have happened, but that could have been a very small mutation, just changing something in somebody's genome and then spreading through the small breeding group. So that, in that respect, it's a goal, and steps have been taken towards it. But you would expect that something like that ought to be true, just from what's known about the history of evolution of Homo sapiens in very recent times, without much opportunity for selection to have had any effect. Maybe a small effect, but not much. So that's, I think, that's the tendency of thinking, at least my thinking, and many others, on how theories of universal grammar have changed. But the idea that there is universal grammar, that it exists, that can't be controversial, unless you believe in magic, for the elementary reasons that I mentioned.